Welcome everybody to Today in Space. This week we have another episode of People of Science, and joining me today is Jordan Noone, who will tell you a little bit about himself a second here. So Jordan, thank you so much for joining us on the podcast here.
Thank you. I'm excited to be here today.
So let's dive into it. I think tell us a little bit about what you're doing now, a little bit about you, and then let's dive into like where you got started in STEM, your STEM origin story.
Okay, right now I'm co-founder and a general partner here at Embed Adventures. We're an early stage venture capital fund investing in startups beyond launch. So when we say beyond launch, it's really looking at what happens as launch costs come down, as lots of success and investment is going into the commercial rocket launch world. But what happens next when launch economics change and all of a sudden areas that in space that didn't make sense 5 years ago, 10 years ago, they start really taking off and thriving in ways that are really unexpected today.
Mm. Yeah, absolutely. So, um, tell us a little bit about like Embed Adventures. Like, it's a venture capital fund, right? You guys are looking to invest into these new startups that, like you said, after launch. What like started that? What was the choice to go to Embed Adventures?
I think the embedded story really starts about 2 years ago. Then back when I was full time at Relativity Space, which I had started back in 2015. And it started when Jenna, who's my co-founder and general partner here at Embedded, Jenna Bryant, she reached out to me for an event series she was hosting. I hadn't known her beforehand. She reached out to me cold on LinkedIn and
Mm,
asked if I wanted to join this event series she was throwing, bringing together venture capital backed founders and innovation leaders from the United States Department of Defense.
mm,
And she brought together an event that, not only were there guests that were people that I was having trouble getting access to,
mm,
but they were very open and kind of candid about the future of how they saw this collaboration acting out. And we kind of came full circle with that, with Embedded. We'll touch base on that later. But, I was full time at Relativity. Jenna was at her fund prior to Embedded. But she had a big passion about seeing the two groups work together because her brother is a Marine Corps Osprey pilot. And
oh,
he had, he was flying his Osprey around. He was doing stuff around the world, but he didn't have access to Wi-Fi because of certain, latency and technology limits within the infrastructure they had. But
yeah.
she was seeing startups, some of which she invested in her prior life at her prior fund, that were solving those same issues, but were barred from working with the U.S. government because they had certain, let's say, key customer accounts that created, foreign influence and control that barred them from working with the US government and US military. So she started asking questions, and it became the themes of these events on why do startups dither from solutions that work with the US government, or what is causing these trends where these new technologies are applied first in the consumer world, but never in national security because of some of those consumer relationships causing kind of conflicts of interests or influence that bars those US government relationships. So that was really the foundation of Jen and I getting to know each other. And fast forward a year of her and I keeping in touch after that event series, continuing to talk on those same themes, but also on other things within the venture community that we wanted to see different. Myself as a founder, herself as an investor. And that led to a point where, and unannounced to her, we'd kept it fairly quiet at the time. I stepped out of my full-time role at Relativity and it got the company to a point in size where I wanted to touch base on the early stage
Mm,
opportunities again. And Jenna realized it was an opportunity to kind of reel me into the investment side where I can work with founders at the early stage, kind of, two founders in a garage stage of
mm,
company, and for eternity by working with them, growing them, mentoring them. And then as they kind of take off and go to the next set of investors and larger scale investors, I can return to that early stage, kind of avoid
mm.
what I refer to as a champagne problem of growing companies past the size that I really enjoy working with them.
Oh yeah.
But Jenna had approached me and asked if we wanted to create the fund that we wanted to see and that we had talked about for the year prior. And I said yes. I don't think I said yes immediately, but something where I kind of teased it along for a little bit, and with some thinking about it, it was an amazing opportunity to be working at that early stage and with early
Mm,
stage founders, and helping back them in the way that I would have wanted to be supported.
right. It's such a unique like. First of all, like kudos for getting yourself out of that because I've I've worked at enough startups, especially like in the manufacturing realm or tech realm now at this point, that I've seen, kind of a changing of the guard.
Yeah.
The startup people end up leaving, and a lot of them are kind of like startup hardcores. Like they just love that. I like the smaller business. I like the grind of making the impossible possible.
Right.
And once it gets to the let's keep repeating it, yeah, I get the wanting to move off. So the fact that you were able to do that, how old are you again?
I'm
Don't mind.
28 now.
28. Jeez, you've really like grabbed it and ran with it. Like where did that passion to do startup? Where did that start? Like was it something you were always doing businesses growing up, or
It's a good question, and I can go over some of my backstory, and I think
please?
it's buried there, and I'm
Okay.
slowly even figuring out for myself where that drive comes from and kind of
Mhm.
what motivates me.
Yeah.
And we started Relativity when I was 22, and I believe Tim was
Mhm.
25.
Wow.
And Tim's my co-founder, and he's still CEO there, today.
Mm.
But before that, Tim and I knew each other from USC's rocket propulsion lab. We went to school at USC together.
Cool.
And I think that's where a lot of that drive at least started to manifest,
Mm.
where I was running USC's rocket propulsion lab. Um, I I started in the lab actually my first week of school. They came to
Wow.
my kind of introduction to aerospace class, and they brought a big rocket that they had built, kind of this carbon fiber rocket that was beautiful. And it's a really nice rocket, the one that they flew
Mm.
first as a lab when they were founded. But they were telling us about this, vision they had in this goal to be the first student group to fly a rocket to space.
Mm.
And space is defined at the von Karman line, so kind of 100 kilometers up,
Mm.
and so quite high. And when you normally hear about students flying rockets, it's competitions to hit, who can get closest to a mile or who can launch
Right.
an egg and land it. But this was flying a rocket to space, and
Yeah.
something quite extravagant. And it was this self-set goal where it wasn't a competition, it
Mm.
wasn't industry sponsored, it wasn't even kind of university sponsored. It was just students really wanting to push the limits of what they could do.
That's so cool.
And I fell in love with it. I went to their first meeting and essentially never left. Where for the next 4 years, I spent 2 years as one of the lab leads, and then 2 years at the head of the lab. I was
Wow.
composites lead, so making the carbon fiber structures for a number of years,
Mm.
and then took over the entire lab as a junior. And running that group, I got a ton of hands-on experience, whether on the management side, the structural side, the engineering side, regulatory, government affairs, insurance. That's kind of
Wow.
all-encompassing when it
Yeah.
comes to a rocket launch. It's much more than making a rocket. I was the
Right.
first student and youngest person ever to get FAA clearance to fly a rocket to space
It's
there.
amazing.
And that actually was the biggest burden that my generation had to solve. Was we were making the rockets, the test fires on the ground were going well. There was a decade of research and engineering ahead of me that was built on, but the FAA wouldn't give us a license. They're like, who are these kids saying they want to fly a rocket to space? It's a
No.
bunch of 19-year-olds. No, and they wouldn't even look at it.
Right.
And there was a big push to get the FAA, the Bureau of Land Management, to agree on jurisdiction,
Mm.
agree with working with us, trust our simulations to the point that they were comfortable with the dispersion analysis. Where is this thing going to land?
Right.
And I think it's really that experience where it was that self-set goal, and not having anyone kind of telling you what you should be doing, but also where your limits are and how
Mm.
to do it. We had a goal, we wanted to do it, and then going to industry after that, despite going to some very amazing, exciting companies. All of a sudden, these are fairly large companies with their own culture, their own
Mm.
baggage, and their own kind of challenges, where we would face issues, and then all of a sudden it was you blame the people in the other building, you blame the other department. It wasn't something in your control where you can go fix it, because all of a sudden this is a multi-thousand person company
Right.
where it's someone else's fault and you're stuck dealing with it.
Yeah.
I think there was a big drive at that point, both for myself and Tim, going into the Relativity founding, where we had experienced setting our own goals, building our own organizations, kind of controlling our own destiny, and we lost that dramatically quickly going into industry after graduation.
That's such a unique like I've experienced that in a much smaller level, but it's still the same. Like this podcast has been that way for me. There's been no no limit set by anybody else. Our 3D printing lab, same thing. It's just whatever we can make. You come with us an idea, sure, we'll figure it out. Um, I don't know if that's like a scientific way of going, like if that's like the scientist who just is like this new era of like our generation, which is, we're in an industry that's been around for over 50 years, that's so used to doing it the same way, and we've got so many tools available to us that it's hard for us not to want to do whatever we want, right? Or at least set our goals to whatever we want to. So that's so cool that you guys had that in academia and then brought that to the business. So let's talk about relativity a little bit. What did you guys start with? What was as someone that went from the scientific road to the business
Mhm.
road, I think this is the what I hope this segment does for people is people that are either applying to college or in college and they start feeling that that
Yeah.
like I'm out of school, I'm going into the business world. What is this?
Mhm.
Like how is that for you guys at building a business? I mean, that's a whole nother
Right.
thing.
It was a learning experience,
Mm,
definitely, because neither myself nor Tim, we neither of us took a business class, a
mm,
finance class, a legal class, engineering entrepreneurship class.
right.
I never, I think in college had the expectation I would start a business or be in the business world. I had thoughts
Mm,
on, do I get a master's degree? Do
yeah.
I, do I do a PhD? And I remember even I did my grad school applications my senior year, and then I took the GRE to submit alongside them. And I did so poorly on the GRE that I was like, I can't apply. I can't submit this. I was embarrassed. I didn't know I could do, that poorly in writing. And
I reached new limits in that area too,
I
so
know.
I'm with you.
It was surprising, but something
Mm,
where, I was excited to go into industry. I didn't have really a set vision for what I would do if I went into grad school.
mm,
But I didn't really know what I wanted my career to look like. It was a little haphazard. So I'd never really thought down the entrepreneur route or the
mm.
business route. And it was something where, it's kind of funny, the origin stories of how this stuff comes together. Where, for myself and Tim, Tim was at Blue Origin. He was full time at Blue Origin. He graduated about a year and a half before me.
Okay.
And so he had been there for a bit. I was at SpaceX, and I started as an intern. I started as an intern doing propulsion on Cargo Dragon. So it was the first Dragon missions to fly on the 1.1 Falcon 9 version 1.1, which is like
Wow.
flight 6 and 7. I think 7 was the first Dragon on 1.1, and 6 was the Cassiope mission. And it's weird to think that flight 6 and 7 were only like, 6 years ago,
It's
7 years
crazy.
ago. It was 2014,
Yeah.
and it was like a year between flights for Falcon 9. It was
Wow.
a very different era. But I did propulsion system qualification for Cargo Dragon to show that the vehicle could fly on 1.1 with updated vibration loads and
Hmm.
structural loads and the like. And as I converted from an intern to full time after, I think it was CRS 4, it
Mm.
was Dragon 6 CRS 4 was the first mission I worked on. I converted to full time. And I had the opportunity to move in with some of the other interns who were also converting full time down in kind of Redondo Beach, South Bay here
Cool.
in LA. And I got cold feet. It was something where
Mm.
there was something in me, and I don't know if there was that same drive I was talking about of, kind of controlling your own destiny.
Yeah.
But I got cold the moment that I saw a lease with a 1 year commitment. There was something in the back of my mind that said, I'm not ready to sign that, or I don't want,
Mm.
a lease or where I'm living be what stops me from doing. I didn't know what at the time, but doing something else. I think the big company vibe, and SpaceX was, 3,000 people, I think, at the time.
Right.
They're up to, about 10,000 now. But 3,000 at the time, where you
Yeah.
start to feel even some of the big company
Definitely.
politics and woes at that size. So for me, I ended up moving back in with my parents in Pasadena, and I started doing the hour-long commute each way to Hawthorne. And that's something where, to pass time during the commute, I started calling my friends, and one of them was Tim. And that's where we would talk on, what we saw in industry and kind of trends and the vibes we were seeing. And one of them was 3D printing, which metal 3D printing was pretty novel
It's
at the
true.
time.
Hmm.
Super Draco on Crew Dragon was I'd say the initial success of 3D printed engines,
Mm.
and that was very very novel at the time. And now it's mainstream. If you don't 3D print your engines, you're pretty silly. But it was really novel at the time, and then not demonstrated. And I transitioned from working on cargo drag into then the pad abort vehicle, saw the pad abort vehicle, success flight, and then transitioned to designing hardware for Crew Dragon,
Mm.
and very much saw the success of 3D printing with Super Draco, and started asking the question. And Tim, had a parallel journey at Blue of seeing initial success with 3D printing, and then asking the question of, can we print more? And it
Yeah.
was often viewed, and still is in certain ways today, it was viewed as, an art form where it's, something that fully takes advantage of the benefits of 3D printing. Oh,
Mm.
that's not a functional rocketed part. That belongs
Right.
in a museum, or that shouldn't be in a turbo pump. You can't use, fatiguing components like a 3D printed one in a turbo pump. And people have these very strong critiques on 3D printing where we wanted to see them advance. And it was like,
Mm.
have people tried these? And people would say no. And it's like, well, why are you so negative on it? And it's really deep rooted. It's something that's still, I think, intriguing and wraps into some of the embedded investment thesis today, that manufacturing is such a deep rooted kind of value in so many people, of like the how you make things
Mm.
part of someone's career. Whether it's a blacksmith in a shop, or a manufacturing process in a factory. You
Mm.
have entire cities built on top of certain manufacturing processes. It's very deep rooted. So being able to transform the manufacturing within any organization is very, very high inertia. And Tim and I both felt that, and we talked about it on those drives where people just didn't want to adopt 3D printing. And then that started the rapid journey for us, as far as, okay, if these companies won't do it, will another company do it?
Mm.
And then us, kind of having the shower thought of, well, what if we created a company to do this?
Right.
And then very rapidly, we were like, maybe a company could do it. We pursued some financing. We kind of learned about the business world and startup
Mm.
world, stepped out of our other jobs at SpaceX and Blue, formed Relativity, and the kind of the rest is history at that point. I know I kind
Wow.
of skimmed over there, learning in the business legal world, but I'll pause as far as that was kind of the foundation.
Fair.
It was very, if I didn't get cold feet on signing that lease,
Right.
we wouldn't have had those drives, and I wouldn't have been kind of postulating these ideas around, because I would have had a 5-minute commute instead of an hour.
Right.
And it was that cold feet, and where my parents happened to live compared to Hawthorne, which is driving through downtown LA here,
Mm.
that I don't know if Relativity would have ever existed.
That's such an wow. I got chills thinking about that because similar path, took many drives at a job, trying to figure out the next step. So I hope your back is okay. That's my first thing, because my back is
It is.
terrible. Uh, but wow. So I think a lot of people get stuck in the path that's already been laid out. Like for you guys, right? Relativity space. Everyone's just gonna say, "Oh, they already did it," blah blah blah. But it's like it was not a known path for you, and I think that's an important thing to point out. Like you had that gut feeling, you went after it, and it ended up working out. Um, so relativity space, it's going to be hard to put this in a nutshell, but in a nutshell, you guys went from we could 3D print some things of a rocket to essentially 3D printing the entire thing, right? In a nutshell.
Yeah, we were seeing the success, and if you look back in history of kind of metal 3D printing, the success of printing rocket engines was really shown through, there's some NASA work in the early 2010s.
Mm-hmm.
SpaceX really pioneered with Super Draco, especially for human spaceflight. That was really unheard of at the time, and is still the only 3D printed human spaceflight engine there. So it was really, really unheard of, but we were seeing that success. And it was something where there's all these benefits you see in 3D printing,
Mm.
where you don't have tooling. You can translate manufacturing, kind of digitally. It's digitally designed manufacturing, where you push your complex design to the factory, and then it's made. You don't have to translate that design into work instructions and
Right.
quality assurance. It's kind of this data-driven process where you have digital instructions coming in
Yeah.
to the machines, and you have a lot of things you can verify digitally coming out, because it's a very machine controlled process. It's kind of data driven by nature on
Mm-hmm.
inputs and outputs. So it was something that matches the trends you see in the rest of the world on data driven, on software defined. Then you can get complexity you can't get otherwise. You get away from the inertial elements that slow down a lot of aerospace, which is all of the checks that happen in a factory, all the quality assurance, all the verification of manual installation steps. You
Mm.
move towards that naturally while getting improved performance, features you can't get otherwise. And then, the strongest, I'd say alignment there is on mass and optimization of structures, where in
Mm.
traditional manufacturing, whenever you do a machine operation, you're kind of like the more optimized a part is, the more manufacturing steps there are, you increase cost and you
Mm.
increase lead time
Right.
because you have more machines, more steps, bigger factory, whatever it
Mm.
is. But with 3D printing, you get this natural incentive alignment where the more optimized your structure is, it's less time in the machine,
Mm.
less raw material used. So it's actually cheaper and faster to make this more optimized product. And I think people
Mm.
really don't get that.
No.
Where you see this incentive alignment, and people look at some of even like Relativity's early prints or what's coming out on the first vehicle, and they're like, oh, you can make that by bent sheet metal.
Mm.
And it's like, well, on the first one, sure, parts of it can be replicated by sheet metal. Parts of it really can't be, as you look on the insides.
Yeah.
But what happens where now on flight two, you can add more features, and flight three, you can add more features. And every time you add more
Iterate.
features and you optimize the structure more, you're actually making this more complex product faster and
Yeah.
cheaper than the first time. And you build this flywheel where with traditional manufacturing, you actually slow down the flywheel. You have more manual labor steps, you have more people involved, you have a bigger production effort in general. There's only so many good technicians in the world, especially for aerospace. It's scaling production. If you look at SpaceX or anyone, scaling production is harder than the first vehicle. So what happens if you have infrastructure like 3D printing that allows you to scale production in a software defined manner rather than through labor? And it's dramatically different, and it's still interesting to see some of the commentary on relativity where we've built printers, and to actually trace back to some of what your question was, we saw that success at a small scale. We knew it had to scale up to bigger printers.
Right.
We designed those printers, we did the napkin math as far as can a printer print fast enough at a physics level
Right.
to be economical in this, and we demonstrated that on a napkin side and then had to spend a couple years developing that, and the printers are getting faster and faster every day there, but something where it's this kind of underlying infrastructure that has parallels to what you see as far as the flywheels in software, where it's just faster and faster every day, more complexity, more layers deep on infrastructure and APIs and what can be done in a fairly abstracted manner.
Mm.
And a lot of the world will still look at relatively 3D printing and say, oh, I can make that, on a mill. I can make that in a sheet metal bending machine. And they're the ones that'll be more and more blown away every time Relativity has a more complex product coming out of the door, essentially for free because it's software manufacturing. There's no factory change for that
Right.
extra complexity.
I'm blown away. I mean, working in 3D printing on a daily basis at a day job and then doing it when I come home, I'm also blown away by the lack of, like, I don't know if it's imagination of like what it actually capable of, but like bring an idea from, like you said, the back of a napkin to reality. Like
Yeah.
it's kind of hard to define, but once you see it, like you've seen it, like I've seen it, like it's hard not to keep that Pandora's box of what we can do open. So it's interesting now that you've phrased it that way. It makes complete sense why like Embed Adventures was your next step because, and correct me if I'm wrong, but it sounds like you're looking for these things that seem like they could be innovative ideas, new ideas, and you're actually open to seeing, well, can we do this?
Right.
And 3D printing, I mean, to touch like on one more thing before we, because I do want to talk more about Embed Adventures and this new thing you have going on. Um, with 3D printing, I think, I worked in a traditional manufacturing environment, injection molding. So I was around tool makers. I was helping them kind of bring their, because there's no more apprenticeship program. So going more to that problem that they're having in the aerospace field, these skilled technicians took a very long time to do that. And there's not schools that are really teaching this, and if there are, there's not a lot of them. So it's like all these people are in their 60s, you know, they're older. They're not going to be around that long. So if we don't find a way to get additive in and get these younger people into manufacturing and being hands-on, like there's no hope for the future of the industry as it was. So I think it's a tool that can be used. Additive and traditional, they'll be together. I get in plenty of Twitter arguments with people who are very anti 3D printing, but I try not to do that as often as I can. Um,
Yeah, it's interesting to see the backlash there and some of the negativity.
mm,
And part of it too, I completely agree with what you're saying, that there's not enough of kind of those hands-on programs in education. Like my middle school stopped teaching the woodshop class that I took. Even some of the college programs,
yeah.
it's interesting to see because people view, especially within university administration, they'll often see the hands-on programs as liabilities.
Mm,
And that's something that I find really disappointing from a couple of perspectives, because like, yes, the programs can be dangerous. You're working with heavy machinery, you're working with chemicals
hmm
there, but the way that the universities approach them, especially in recent times, it seems like it's been a transition over the last kind of 5-10 years,
mm,
and has been, these projects could be dangerous, therefore take them away from the students. And
right.
I view it as something that I think was even beneficial. I was reflecting on this, within, it was a couple months ago, even within like the business world, right? Where you show people a piece of heavy machinery
Mm,
and you tell them it's dangerous, never touch it, look away. And what I was trained was, this is a piece of dangerous machinery, heavy
hmm
machinery. This is how it can be dangerous. This is how you figure out in ways it can be dangerous and think about it. Here's the precautions you take. Here's the procedures you take. Here's the equipment you wear. And here's how to approach a very, potentially dangerous piece of machinery in a
mm,
way where you account for the risks and you come out safely and you have a successful outcome.
right.
And the way that the universities, and I perhaps should generalize that more, that education has tackled those hands-on projects is, oh, they could be dangerous, teach people to look at dangerous situations and walk away, turn their
Mm,
back to them. And I think there's something really valuable even for me in my the business world, that I learned from running a mill, running a
yeah.
lathe, or running a filament winder, right, running a robot, where you account for the risks and you come out successfully,
Mm,
rather than taking the non-strategic approach of just run away.
mm,
That's why I think we've been able to take certain business risks, as far as standing up a company, launching a fund, doing an
right.
investment that could be very risky, very dangerous. But you look at it strategically, you tackle the challenges, you account for them, and if you check every box correctly, everyone has a successful outcome, despite it being a risky situation. And that's where you see that
Right.
transformation, is where you kind of approach the risk and you tackle it, rather than looking at risks as something to run away from.
Mm,
And I think there's some parallels there that are unfortunate within, the greater education community, where these hands-on projects are not, being accounted for, in a way that's what's best for the student, but
right.
instead for what's best for the bottom line on a liability side. And
Mm.
I do get rather disappointed in seeing that trend.
Yeah, same here. And I mean, I'm not sure what I can do on a personal level, but sharing your story and your opinion on those kind of things is, I think, where I can start.
Mhm.
Um, for man, where do we go next? I think this is a good transition to where embedded is right now. So uh, do you guys let's talk about the latest, actually. Let's go to this cooperative R&D agreement you guys are having with first of its kind with the United States Space Force. So let's dive into that. Tell us a little bit more about that and like how that came around.
Yeah, I think it ties together a lot of the threads in my life and a lot of the threads in Jenna's life as well.
Mm,
Where if you rewind 2 years ago to that original event where Jenna and I met,
mhm,
and her underground webinar series she was throwing to tie together defense leaders and venture capital backed founders. The actual first guest for that series that I went to 2 years ago was one of the signatories on the CRADA for Embedded. So we kind of all went our separate paths on, Jenna bringing us together for, this event. I was at Relativity, she was at her fund, we had this DoD speaker. And then 2 years later, we're all the signatories together on this collaborative R&D agreement.
mm,
And it's something where the origination of that agreement really came from, Jen and I looking at the venture capital space where we wanted to invest. And that was specifically these space sectors beyond launch, so kind
mm,
of things other than commercial rocket launch that are enabled by lower costs there. But that's an ecosystem that is relevant for national security. enabled very much by US government partnerships. You see a lot of these areas that are kind of on the tipping point of economically viable.
Mm,
And that's where the government often steps in, whether that's in, the origination of, electric vehicles becoming a thing, kind of 20 years ago,
right.
and government spending there. If you look at COTS and commercial crew with SpaceX, where
Mm,
those were very much pivotal in the success of these programs because they're on the tipping point of being economically
right.
viable, and the government can help accelerate those.
Mm,
So when you look at these areas beyond launch, so let's say in-space power generation or
mm,
lunar logistics, lunar infrastructure,
hmm.
and then kind of next generation geospatial intelligence and communication. A lot
Right.
of those are areas, some of which are viable, but some of which are not economically. But as we look at investment timelines, we're looking for companies that'll be thriving and growing in, 7 to 10 years.
Right.
In the same way, if you look at SpaceX, and people tend to lose track of time when it comes to, the age of some of the companies that are in the prime of the space news today.
Yeah.
But no one 20 years ago was talking, especially in mainstream news, about commercial rocket launch. But SpaceX, Virgin, and Blue were all originated in the early 2000s.
Yeah.
So it took 20 years from the point those companies started to the point that people were talking about them daily.
Right.
And you would see, even within the space community, them talked about daily, but outside of the space community, people talking about rocket launch.
Mm,
And we look at sectors that are on a similar timescale. So if rocket launch was originated 20 years ago, and the first checks into commercial rocket launch companies that are thriving today
mm,
were 20 years ago, we look 20 years in the future for what are the sectors that people will be talking about in 20 years
mm,
every day, whether that's, transforming the moon, space-based power generation, space-based manufacturing,
mm,
next generation telecoms, things like that, where, hopefully rocket launches will go from being, top of the news, top of the space news,
right.
to something so mainstream that they're never talked about. You
Right.
hear about what people are doing in space, what equipment's doing in space, new
Mm,
new space applications,
yeah.
but an actual rocket launch happening, that's going to be so frequent and so boring that it's no one's going to talk about it. It's going
Yeah,
to
it's
be a
like I drove
summary
to work
metric.
today. Okay.
Yeah,
Yeah.
exactly. Exactly. So we look for what's built on top of that.
Cool.
But the way that the CRADA came together was, very much seeing the need for that government private collaboration. We
Mm,
think that's the private investment world working with the US government on these sectors that are on the verge of being economically viable.
yeah.
We have the same goals and we have areas that are very complementary, where we're looking at sectors where we're making bets there's going to be a big customer in 7 years, in 10
Mm,
years. The government's looking at sectors where they want infrastructure, but there's no companies supporting those.
right.
But they have the big pockets where they can move the entire industry if they have a big program go through. But they don't know what startups are coming. It's super hard to predict timing
Right.
within, these sectors. So what happens if you start communicating more? Where,
Mm,
we're seeing a startup that is growing, could be successful, could solve a government need, but the government doesn't know it's coming.
mm,
And the government has a big area where they want to do a big check, big spend, big infrastructure revamp, but they have no idea if a startup's going to be ready. They
right.
don't know if one of the
Right.
incumbents will be able to handle that level of transformation.
Mm,
So we do it in a way that's no funds exchanged between the two groups, and really it's an education and informational exercise where we have the same goals, we have the same sectors we want to see stood up. We complement each other in timing, us early stage, them generally late stage, or them having opportunities that solve some of the valleys of death within the venture ecosystem, where you're ready to grow, you need a customer, you need some risk buy down on growth by having this opportunity lined up, but no one's talking. And it's something
mm,
where I think that's really why, and people have asked the question of why did we get the CRADA as this young fund. We've
mm,
done 8 investments to date, only I think 4 of those have been announced. Then, but this young fund, we don't have a 30-year track record, but we were the ones, and starting with Jenna 2 years ago, open the door and just communicate. And we don't need, as a fund, to be paid by the government to do so. We're just passionate about US national security. We're passionate about the space sector. We want to see success. And we're the ones that approached them and said, hey, we've seen Kratos in other areas. Let's figure out what this could look like. And they loved it. but we were the ones to knock on their door and say we want to do something and provide some information on what we're seeing in the venture ecosystem or opportunities where the US government has missed out because they don't have eyes and ears in that early stage ecosystem
Mm,
that we as venture investors naturally have very strong insights into. And it took only, 7 or 8 months. It was quite a while to figure out how to get the creative phrased and
right.
which group within the Space Force, which is still very emerging and young,
So new. Yeah.
where it fits because it's something where it's new, everyone wants it, no one knows where its home is. So we spent a while bouncing between various offices, and
Mm,
everyone we talked to was beyond excited. But the office, we're in right now with SpaceWorks, and they're within AFRL, was very receptive and mirrors very much what they're doing internally, and even the goals that have been announced with, let's say, an orbital prime.
yeah. A lot to break down there. That's
Yeah.
thank you for breaking that down. So first, I think it's super important to point out like the relationship that you and Jenna have, and what Jenna has done as a piece to connect the public and private. Like there's if we're talking about if this kind of an episode is to get people into STEM and get people into this space industry, which is going to need more people with different ways of thinking, that communicator to connect the brains, like that is such a huge piece that I don't think so many people even know is an option for them. You don't have to be a STEM, you don't have to be some, science prize winner to influence the space industry.
Yeah, no, absolutely. And, Jenna's very much my role model as I
Mm,
look at this, as far as, really taking your strengths and focusing them in a unique way. And people often ask me, you know, what can they do to have a really successful career? How can they kind of stand out? And the way that I very much phrase it is, find a couple areas you're either super passionate or super strong in, and find the intersection of them in a way where you uniquely, or you're one of very few people that have this combination of, this passion and these skill sets that overlap in a way that makes you really stand out. Because,
mm,
there's a million people in the world that care about national security for the United States. There's a
right.
million people that are good communicators. There's a million people that operate in the early tech space.
Mm,
But who can kind of blend them together in a way to champion it in this way that's groundbreaking and first of
yeah.
its kind, because of the network, because of the passion, because of the way that it's kind of tied together. And for Jenna, she comes from early stage tech recruiting. She's
Mm,
the most non-traditional, venture background of anyone I know, where she started, Auburn fashion design. And in fashion design, she learned AutoCAD. And AutoCAD's, for designing kind of fashion cutouts and print cutouts. So she had, 10 years ago, this kind of, she laughs at it a bit now, but what was called, tech experience of knowing
mm,
AutoCAD. And she started working for a boutique recruiting firm here in Los Angeles, doing early stage tech recruiting, and then eventually started her own firm doing tech recruiting. And
wow.
she started to get to know everyone in the LA ecosystem who was an engineer, everyone who was doing something. She's very good at kind of getting people to open up and relationship building.
Mm,
And something where, a lot of these early stage hires she was working with, and these early stage startups like Snapchat and Tinder and Oculus that she was working with, kind of the birth
wow.
of the LA tech ecosystem a decade ago,
Yeah.
those first engineers are often the people who start the next companies, right? Those early hires at startups often start that next generation of companies.
Mm,
So it's something where all of a sudden she was in this corner where she knew everyone in LA that was starting a company. And that got
right.
her picked up by the venture community. The fund she was at before Embedded noticed that she knew everyone. They started working with her initially on a contract basis to recruit for one of their startups, and then eventually brought her in as a full partner at the firm because she had such good deal flow and she knew everyone. And through her recruiting experience, she was able to really essentially evaluate people quickly. Are these people that are
Mm,
going to grow as quick as a startup does? Are they going to be able to handle, the pains and pressures of growing a startup very quickly? Because she had a skill set that was very good at evaluating them from a decade of recruiting experience. So bring all of that together, and then what she wanted to do of tying that together with the national security side, kind of a different culture as well, because it's
mm,
something where, to your point, she would get lots of pressures, and I see this day to day still as well, where people are like, why is she in venture? What has she done to make herself like be in venture? And it's something that is very disappointing to see, because from my perspective, her combination of passion for the national security organic deal flow through her network and ability to tie people together in a very
Mm.
organic manner where they just want to open up with her. They want to share with what they're working on. She can bring together the Space Force and the venture community in a way
Oh
that no
yeah.
one has before. But you see so much of the old guard look at her and say, oh, her background doesn't fit. Why is she here? And it's extremely disappointing to see. I've seen it very much from kind of every perspective, every community we work with,
Sure.
where they see that novel background, they don't see value, they don't see the combination of strengths. They see someone from a new background who doesn't fit the mold,
Right.
and they ask questions. It's very disappointing to see, especially from the venture ecosystem that represents itself as forward leaning,
Mm.
as willing to adopt new ideas so quickly, has demonstrated that with things like SPACs, where they can turn on a dime and change how they invest, how they act. But when it comes to things like novel backgrounds and diversity,
Mm.
they're very closed door. And I've
Yeah.
kind of had to witness that firsthand as we've put Embedded together. But to bring it back, to strengths and why I very much value that, it's, she has her strengths and she's blended them together in a way where I can't think of an industry better for her than
Mm.
venture, because of that deal flow, the network, the national security, the openness she brings, an ability to evaluate early stage founders.
Mm-hmm.
So from my perspective, I can't think of a better co-founder and co-general partner here.
Yeah.
But it is a kind of a strange world on how other people view it.
Yeah, and that old guard thing, I don't think it's going away. I think it's gotten better. I think it's something anyone who's thinking differently or outside the box or has, like you said, novel skills. I think
Mhm.
it's going to be like that for probably at least 20 years, right? That next stage you guys are looking for. Another thing I wanted to unpack as an observer outside the industry, I think one of the cool perspectives I have is I've got an aerospace engineering degree. I'm super passionate about space, but I don't work at a space company, so it leaves me open to look at the whole industry with hopefully less bias. Um, and there is so much work that needs to be done if we're going to achieve the things that we want to do. Have continuous human space travel available to everybody. There's going to Mars has been a goal that we've wanted to do, but there's I think only now we're pulling out of people like NASA. Like, yeah, there's a lot of stuff we got to build before we get there. And the more I'm learning this from you, and I've been doing my research about what Embed Adventures is as one of many people and essentially STEM superheroes that are going to be trying to tackle these new problems. Um, I think it's going to be really exciting to see what you guys do. Is there anything specific that you guys are really looking forward to, or is it just really kind of open? You guys are just open to whatever's the next thing of who's ready kind of thing.
It's it's interesting because we look at the space ecosystem very much that there's a lot of activity in launch.
Mm,
There's a lot of activity in launch.
yeah.
And I don't think there's the same demand for satellite customers. It's why you
Mm,
see, let's say, some of the rocket companies vertically integrating into satellite manufacturing,
right.
and it's to help secure what is a fairly nascent satellite environment there, where yes, there's increases because of Starlink, but that market is taken by SpaceX.
Right.
There's some other growing opportunities in the constellations, but I think there's going to be, and as we think about what space industry will look like in 20 years, it's much more than telecoms. But
Oh yeah.
who's funding that today? Who's helping make that real? And you see a lot of activity in space tugs. You see some activity in,
Mm,
like, next generation chemical or electric thrusters for
hmm.
spacecraft. But who's helping instill a lunar economy?
Right.
Who's helping build the next generation of ComSat? Not just these small scale, kind of mass manufactured Leo birds, but who's going to reinvent the geo satellite? Who's going to reinvent GPS? Who's going to reinvent all of these kind of auxiliary systems and areas in ways that are more transformative? Like the space tug
Mm,
market is one where it resembles, in my mind, very much the launch market like 4 or 5 years ago, where there's 100 companies on paper, fairly hard to predict who will win. We've definitely seen success stories. Relativity has been one of those where we were one of the 100 launch companies with a paper idea 4 or 5 years ago,
yeah.
and we kind of broke out of the paper company list. But in the space tug market, there's a lot of space tugs, but who are they tugging around?
Right.
Where is all of this demand of other satellites that's supposedly there? And I think we will need to see, but it'll be slow and a little painful, a transition of the investment market from continuing to double down on launch to
Mm.
instead look at some of these next sectors. But the challenge, and it wraps into some of the embedded thesis, is it's very rare to see a check into a sector that doesn't exist yet, right? People want to follow signals. They
Mm.
want to say, okay, launch is growing. This is the successful launch companies. We're going to continue
We're gonna
investing in
do.
them.
Yeah.
Or launch is a sector where we know the mechanics of launch. We know what a good launch company looks like. Let's keep investing in launch, even if it's early stage in a saturated market. But I think we have to have people that are more willing to lean forward and say this is a sector that doesn't exist today. It's
Hmm.
not economical today. No one's flying anything. No company's been successful in this sector. But this will be the company that in 7 to 10 years is thriving, and it'll be something that kind of surprises you in the same way that for a lot of people, SpaceX surprised people, where it went through those first 10 years with no one noticing.
Yeah.
And then all of a sudden, 10 years after that, everyone knows who they
Mm.
are. But what sector exists, or what company can we put a check into as the first check in that entire sector, that in 10 years, it's something that's kind of what looks like an overnight success of SpaceX
Right.
there. So that's really where we look, but it's something where we have a very technical team here at Embedded. We're technical, but we still have to make very good, investments on a business side. So some
Right.
sectors we look at and we don't see, even in the space tug market. How do we know that one space tug is not just going to be a commodity versus another space tug?
Mm.
There, where you can guarantee a defensible market around your space tug versus someone else's. And space tugs, it's a logistics effort. It becomes a commodity. So from our perspective, it's really hard to say that any one of these 100 space tug companies will have a majority market share.
Right.
So we look at the space tug market, and it's unfortunate because are we able to invest in any of them? I'd say no, because there's so little ability to predict success or have a defensible advantage versus someone else when you're just wanting the closest, most available tug. You don't care what's on it. You don't care the power system. You don't care the propulsion system.
Yeah.
If they're in the same orbit and they're a reasonable price, you go with them. And if not, you wait for someone else.
Right.
So that market's one that we haven't moved in, and I don't think we will unless someone pops out with a very unique defensible differentiator.
Mm.
But the areas that excite us the most, we split the portfolio in three sectors. One of them, or three kind of major areas. The first one is in space operations, and that's kind of the obvious suspects, kind of the usual suspects of, power generation, logistics, in space manufacturing,
Hmm.
return. It's something that it's cheap to send stuff up. It's expensive to bring stuff back. And we recently announced an investment in a startup called Inversion Space that is doing low
Mm.
cost reentry capsules,
Oh.
where they have autonomous reusable reentry capsules where you can land something anywhere on the planet on demand. And
Wow.
that's something where that could be used for, let's say, in space manufacturing. It could be
Mm.
used for logistics. It could be used for zero gravity research. It could be used
Mm.
for transporting stuff back from a space station, right? Lots of applications that are kind of thriving. But if you want
Mm.
to have a commercial space station, you're not going to rely on a full crew spacecraft that launch 2 or 3 times a year,
Right.
right? People aren't aware there's a trash backlog on the International Space Station because
Yeah.
there's not enough downmass capability. Who's going to do things like servicing trash,
Right.
or bringing back modules that need to be repaired? So there's a ton of areas there where the downmass problem is one we're tackling, and inversion space is the bet that
Mm.
we've made there. But other sectors like space traffic control, space situational awareness, we need significant amounts there.
Yep.
Things like beamed power in space or next generation telecom. So that all kind of fits in the in space operations side of kind of the usual suspects for things you think of,
Mm.
that are going on in space. But then we have the advanced manufacturing side, and that stretches between in space applications, applications for spacecraft, but also lots of terrestrial applications where, I'm a huge fan of advanced manufacturing, a
Hmm.
huge fan of what can be done as you increase the capability and iteration speed of factories.
Yeah.
So we recently did an investment in a company called Chromatic. They're out in
Mm.
Minneapolis, but they're doing 3D printing not by melting filament, but by controlling a chemical reaction at their print head.
Ooh.
So essentially, 2-part resins, 2-part epoxies that can be mixed and tuned, and you can change the mixture ratios, you can change the temperature that they're melted at. So you can get this dynamic range of materials where it's not a melted PLA. It's not something that is kind of the non-ideal plastics or
Mm.
soft goods that come out of traditional 3D printing. but you can have your ideal two-part resin, urethane, foam, mixed in, controlled in the same way that, Relativity controls their printers in various ways through software feedback, through closed loop control, where you can tune these soft goods where it's the ideal material. It happens to be 3D printed. It's not something where you hit this compromise where many people think, and it's often true, especially in the plastic printing,
Hmm.
this is the non-ideal material.
Right.
Now what Chromatic's doing is it's literally any range of material that you could get through a two-part resin, a two-part urethane, a two-part anything.
Mm.
You control that chemical reaction. So that's very much how we view kind of the future of soft good manufacturing and
Mm.
advancement in 3D printing that is not seen today, because 3D printing is a pretty saturated, industry itself.
Definitely.
And then the third area we tackle is digital engineering. So kind of the toolkit that people use for iterating quickly, for moving quickly with hardware design.
Okay.
And that's something where we are pretty unsatisfied with what we see in, let's say, the CAD market. How much mechanical engineering effort goes into, clicking buttons in a GUI,
Mm.
where 99% of mechanical engineering is repetitive tasks that should be automated. And 1% is creativity. Like, how many times does a mechanical engineer in a day plug numbers into a bolt sizing spreadsheet?
Too
And
many.
how much time is spent doing drawing callouts to turn a design into a 2D drawing so you can send it to a machinist to then convert that into a model and do their computer aided manufacturing, the CAM work, and
Mm.
then plug that into a CNC. There's so much friction in kind of sparseness within mechanical engineering workflows.
Yeah.
Is kind of, what does the future of the digital toolkit look like for the mechanical engineer? Because that is a bottleneck for basically any company doing hardware, is the amount of mechanical engineering effort that goes into your product there. And we recently announced we've been incubating a company in the space, in the CAD space there. It's a company called
Fun.
KittyCAD
Okay.
that we announced. So KittyCAD. And with KittyCAD, it's something where we built this thesis around next generation digital engineering tools. And we were very excited by what a company could look like in that space, but we couldn't find any that satisfied the thesis. And it's something that, myself and Jenna got together where we asked the question of, if no company are we satisfied with, should we just do something here in this space and recruit a team to run the company?
Mm.
And we ended up doing that. We started the company back in April. We hired on a CTO and co-founder in July, honestly, July. And then
Mm.
actually now I'm splitting my time partially between, my GP role, general partner role at Embedded.
Mm.
And then I have such a passion for that digital engineering toolkit and such kind of a community of
So
people
cool.
who want to see that I'm running KittyCAD as CEO
Oh, awesome.
now as well. So kind of splitting our time, and wanted to bring that up partially as an example of something we do
Mm.
different at Embedded, which is if we see gaps in the market that we
Mm.
think we have a good thesis on how they get filled, we'll start those companies ourselves too.
Cool. And then find the right people, build it to a point where then they can start influencing the industry, and then pull
Right.
back, look at the industry, and see, okay, where else can we
Right.
help here? Very
Right.
cool. Okay, so you're trying to unlock the creativity of the mechanical engineers to innovate here on Earth, and then potentially wherever else they might be. You're looking to innate like solve one of the problems, which is the bringing mass back. Like let's solve this, and then everything that has to operate right now, because we're launching more things, we need to keep track of more things, and we're nowhere near that. So
Right.
I think all of those make complete sense. I think uh sci-fi wise, let's close out with some fun stuff here. So give
Okay.
give me, like, if you got one or two of like your favorite sci-fi movies, or shows, or whatever it might be, what are they?
Oh, that's a great question. Um, the first one's Westworld.
Ooh.
Has to be Westworld. There's lots of kind of themes within Westworld that resemble, the 3D printing, but 3D printing of people and robots, which is a very kind of different world. But definitely a huge fan of advanced manufacturing. Obviously, the Westworld comics, like applications are a little different. But I think Westworld really represents a lot of the themes, both in intelligence, in advanced manufacturing, and data collection and privacy, that are, highly relevant and I'm passionate about. So Westworld was a huge, I don't want to say inspiration because we're not doing anything modeled after Westworld, but something that highlights a lot of areas that, that I'm passionate about
Mm.
there, and that advanced manufacturing side. Um, Oh gosh, as far as the second question there, um, it's probably I'm a big Star Trek fan as well.
Ooh.
I know I have a bunch of Star Wars stuff behind me today,
It's okay.
but
You can
big,
mix the two. That's okay with us.
yeah.
That's fine.
I'm a little bit of both, but definitely lean a little bit more kind of Star Trek
Hmm.
there. And I'm just a huge fan of that level of kind of exploration and
Hmm.
advancement and kind of pushing the limits of human potential
Yeah.
there, in what humans can do. I don't know if it'll, the first kind of interplanetary, inner star or inner, I'm blanking on the word there, kind of like
Like Interstellar.
interstellar. Thank you.
Yeah.
Interstellar travel will resemble what you see in Star Trek,
Right.
but that level of kind of technology and technology used for good there.
Right.
I like the themes as far as kind of the ethical and moral dilemmas that are tied in with the Star Trek themes and the Prime Directive and
Mm-hmm.
areas there as far as what is technology used for and how is it applied. I think is highly relevant even for the ecosystem here on Earth today.
Totally. Favorite captain?
Oh, Picard.
Oh, okay. Yeah, we're together on that one. Yeah,
Okay,
same
good.
here. There's gonna be a lot of people upset at us, but that's okay.
It's okay.
Um, no, I think I also have that kind of view that so let me ask this big question and see what you think about it. With the way the world is the last few years and kind of short term where we see things, I see space as this potential Hail Mary to kind of revolutionize and refocus us towards let's get humanity to a good place. I think there's a lot of work we've got to do to get there, but I think there is a path there for this next 20 years to build up, grab the excitement and like the same similar to what we had when the moon landing happened. I mean, you see people, you see the like the excitement in their eyes when they think back to that moment, and that was just black and white screen TV. They didn't even have any real connection other than oh that guy just stepped on the moon. Um, are you? I mean, I would assume you are since you're investing into these future companies. But how do you see space's role in helping humanity find a better path than maybe what we're on currently?
That's a great question, and I definitely think there's a level of inspiration to it, to the point you just made, that is valuable. Um, I don't know if it solves enough in the
Mm,
sense that I think a lot of those issues, like I wish the world would change in response to something kind of like a North Star for us as a species or
mm-hmm.
planet, but I think some of the kind of the internal conflict and strife that we have as a species, it doesn't just go away.
Yeah,
And I wish it did.
yeah,
I'd say part of it that you see a lot of divide now. I wish that got unified. You see space getting pulled into that in ways where it's getting politicized, which I think is unfortunate and inaccurate there, and how it's being politicized, but it's being
mm,
used as a weapon on, a verbal weapon
yeah,
on policy and the negativity of doing so. Um, but I think it's a lot of it is, it's kind of tricky to phrase there on what I'd want to see differently. But I think there's a lot to solve on Earth. I don't think we get away from that. I don't think, and it's not what you were saying. I don't think space solves the problems on Earth, and
right.
I don't want space to be viewed as like getting away from the problems on Earth.
Mm,
But I do think there's a ton of economic growth. There's a ton of prosperity where the opportunity to be involved in that, whether it's through education, through training on running these machines,
mm,
through kind of the economic growth that happens, has a huge potential to impact the planet in a positive way.
yeah,
And I do get really disappointed where that economic growth gets viewed as billionaires having fun in space. There's tens of thousands of jobs, hundreds of companies there that support that space ecosystem and growth and kind
yeah,
of the economic prosperity that happens there. And it is still mostly to be seen. The economic potential of space will always be growing,
yeah,
and it's disappointing to see when that is viewed as something where it's having fun rather than economic growth. I,
right.
I think the role of the government in helping enable economic growth there has unfortunately been politicized to the point where it's very very much like neutral now rather than fully supportive. It's kind of
Mm,
caught in the middle between certain political battles in a way where I think it's much more beneficial than certain people are willing to comment on.
Mm. I think that's fair. Do you think that space helps us solve, like, solving problems in space? Do you think that helps us solve problems on Earth generally?
It depends on the problem.
Hmm.
There, I'd say some areas, let's say, intelligence on the climate, monitoring the planet and the planet's health and having good data on what's happening. I'd say that's valuable. I'd say some element as well on the national security side. It's why the United States Space Force exists, and it's why we have a partnership with the United States Space Force, where the Space Force, and I believe you did a podcast on this as well. It was
Mm.
one of your more recent episodes on, the Space Force not being a joke. It's not a meme. It's
Right.
something where, in the ASAT test last week, very much highlights that
Mhm.
space is a very serious domain with very unique problems there. And that's something that I think does need to be solved for the sake of the planet and for the sake of defending the democracy that all of us value
Right.
there. And people tend to dither away from thinking that that is something that needs to be paid attention to. The
Mm.
fact that the Space Force got turned into a meme
Yeah.
at times and a joking TV show, where it's something I wish people took the national security of this country seriously when it comes to that, because I think a lot of people come from a position of kind of either ignorance or privilege, thinking that we, are always going to be secure and that the United States doesn't have threats
Yeah.
there. So I do think space will have an extremely relevant place within that growth and being able to defend the prosperity that the United States is built on.
Hmm.
But I think there's so much political turmoil and so much politicizing of the role of space, of the role of the United States Department of Defense in the kind of the geopolitics of the
Hmm.
planet right now, that a
Hmm.
lot of that on the value of keeping the prosperity of the United States thriving and the opportunity that's here is lost in the politics of
Yeah.
it. And obviously space drawn into that as far as the value that has on the economic growth and machine that is, the United States.
Mm. I That's beautifully put. I think it's obviously a more complex problem than, just, let's go to the moon. Like, it's not that easy to solve all the problems. And I think community and communication. I think what you guys are doing to get people communicating, that's such a huge zipper that we need to pull to
Mhm.
get everything aligned again, because the 10 years of the shuttle
Yeah.
being out, and what it did to public interest in space. People didn't even think we had a space program anymore.
Right.
Um, all of those things we need to pull back together before we can really vertically integrate this whole industry to go in
Right.
a direction that we want it to long term, not just every 4 years, 8 years, when a political party changes house. Um, last words. Anything? So first of all, thank you so much for joining us. This is a blast. We could talk for another 2 hours. Um, I'm definitely looking forward to talking with Jenna at some point too.
Yeah.
Last words for the folks out there, people that are in college, maybe looking for their major, maybe they're outside of STEM. There's a bunch of people looking at their lives thinking, "What do I want to do?"
Mhm.
I think uh, you have such a unique perspective. What kind of advice do you have for the folks out there right now, if they're looking to for anything, looking to get into science, technology, engineering, math, or starting their own company and becoming an entrepreneur?
I'd say that there's a couple things, and I'll tie them together with part of what I talked about today. Some of them I touched base on.
Okay.
But the first is finding that area where you are uniquely qualified to do. And it's a combination of passion, of skill there, but definitely differentiating yourself. Society will kind of reward you in various ways
Mhm.
if you're able to find that area and kind of scale it in the way that you are uniquely qualified to do. I think that example with Jenna
Yeah.
there and her background and how that ties together in a way where she put that into a way where she's amazingly impactful and scaling her impact, where
Mm.
that is very rare to do for people. They follow a mold, they don't have a unique element to what they're doing, or they have a passion and they don't tie that together with an area where they're strong and kind of
Mm.
strong in their day job there. But you can find these really unique niches if you take 2 3 areas that you're really strong or passionate about and blend them in with a way where you get recognized for
Yeah.
doing that So anyone starting a company or wanting to go into a specific sector or career area, that's what I'd recommend, is figure out how to blend those in a unique way. Like your GPA only makes you stand out so much. Straight A's make you only stand out so much
This is true.
there. It's something, it's really hard to differentiate in
Mm,
those areas where you're looking at things where, a lot of people have good grades, but very few people have applied those onto a hands-on project before
mm,
they even went into an industry job
yeah.
there. So that's the first place I'd recommend. And then the second, and this touches on the STEM education element and even some of the kind of the policy and solving problems on Earth, is very much, there seems to be almost like a dithering away from education being somewhat of like a meritocracy in various ways. And I say
Mm,
that where there's a lot of activity on the SAT scores. There's a lot of activity on, are SAT scores inclusive? Are they not inclusive?
mm,
Things on, is access to advanced placement courses in high school a good or a bad thing? And it's something where I think there's getting to be this muddy area in differentiation between meritocracy and inclusivity, where people are saying they're exclusive, where the ability to take a advanced class earlier and opt into an advanced class is somehow taking away from inclusivity. But it's something where, from my perspective, if you're in, if you study, if you're in a area where you have access to these courses, that can set off your entire career.
yeah.
That can set off your entire career and differentiate you to be the first person in your family to go to college because you had access to an advanced math class.
Right.
And that is being muddied right now. And I tend not to speak on political items, but very much you see that muddied in California, even today, this week.
Mm,
And then as far as that algebra in middle school is a bad thing for society, that you see advanced placement courses being viewed as something that takes away from inclusivity. And it's something, again, where that's something that someone opportunistically can step into, say, hey, I really want to study for math, and they can start that at 10 years old. Just
yeah.
access to a textbook and getting into a math class ahead of their peers can change an entire generation of students
Yeah.
there and provide opportunity. And it's being viewed that opportunity is actually a bad thing,
Mm,
because it creates divides, because it creates gaps in education, because the students that they happen to get a textbook. Like, I remember my dad buying me a algebra textbook and a
mm,
calculus textbook when I was in middle school. I still have them. They're still on my
yeah.
bookshelf here. That I have those because I read that textbook, that calculus textbook,
Mm,
ahead of anyone else. And I did well in those math classes, and I got into math classes that are currently being viewed as negative things towards education.
yeah.
And I find that just very odd and disappointing. And I have some regard for where that's coming from, as far as that some people have more access than others, but also
Hmm.
many people get access to those not through, things like, pay to play schemes or knowing the right person as a counselor. You get into
Right.
algebra in middle school because you study a bit more.
Mm,
And that studying is available to a lot of people, like a lot of
yeah.
people that are going to lose access to that. And I would
Yeah.
just ask people to kind of pay attention to some of the greater trends in the education system, where the hands-on projects are going away, access
Mm,
to advanced math classes is going away, and the drive for inclusivity is creating less opportunity for people who are outside of the system, who want to work for having access to those
mm,
goals and want to study to get into advanced classes earlier. Those opportunities are going away, for a lot of people.
I personally agree with a lot with what you're saying. And on the inclusivity thing, I think I like sharing the story only because I think it points to the fact that initial, like, okay, so let's start. I had a guidance counselor when I was going into high school who saw that my math scores weren't as high, but my science was very high, and decided, you know what, it's going to be easier for you to just take a lower math class. It's going to be less stressful for you. This is going to be good for you, which
Yeah.
of course it was not. And I felt like I was at the bottom of the barrel, and I had to fight I had to take two math classes. I had one professor, what am I talking about? I had a teacher who just saw that I was working hard and said, if you're up for it, there's more work ahead of you, but you could take two math classes next year. I think you've got it in potential. That alone I think is one of the major moments for me when I realized it was even possible. So when we talk about inclusivity and taking away that I guess cheat code that I guess people are thinking of as that advanced class, I've learned more about my brain and how I learn outside of college than I did in college. And I think if we want, it's less about being inclusive for everybody in my mind as it is about enabling
Right.
the diverse minds and ways of
Right.
thinking than it is about taking away the cheat codes. Get every like hands-on people should be doing hands-on projects. People who are auditory should be listening to lectures and combining that with visual people should be, drawing out the orbital diagrams of atoms and other things.
Right.
Like these are the different things that we need to, in my mind, help people learn how they learn. And
Right.
and if you want to talk about diversity, there is a wide spectrum of the way that people learn,
Yeah.
and we haven't even scratched the surface there.
I agree. No, I agree a lot, and definitely those opportunities for people to learn in the way that makes sense for them,
Mm,
and for them to thrive in the way that makes sense for them, and have access to those. There needs to be a huge push for that.
yeah.
I'd say a huge push for that. But the direction towards everyone has to take the same class, and that is fair,
Mm,
then I'd say that's kind of faulted. And there's unfortunate like a big successful drive for that right now, where the classes that stepped, that allowed my career to be successful, that allowed me to have early access to skills that I still use today and that got me in college.
yeah.
Those classes are gone.
Mm,
Right, the hands-on projects I worked on in college, they
yeah.
struggle to exist because they're viewed as a liability. Those set off my entire career as well. And similarly, things like SAT scores,
Mm,
and kind of standardized testing is being phased out because it has proposed bias in it. But it's something where my GPA in high school was very poor. I'm a very, very poor kind of homework student, kind of regular classroom person. But I got into college partially because I did extremely well on the science and math SATs.
yeah.
And that's something where that got me noticed. I was noticed as someone who had this unique background that was, struggling in certain areas. I was a straight C student,
Yeah.
freshman and sophomore year of high school. I got it together a little bit more towards the end. There, I did realize I had to put some more effort into
Yeah.
the schooling to get into college. But something where the majority of my grades, if they weren't areas I was passionate about, they struggled. In the areas I was passionate about, I did really well, but the SAT scores really anchored that it wasn't a fluke. I was
Right.
actually, talented and not knowledgeable, but those SAT scores are being phased out.
Yeah.
So me right now, if I was applying in the current kind of education policy environment, I would not get into college. I would not have the programs in college if I did get in that led to my current career, which is enabling a whole nother generation of founders and teams to be growing there,
Mm,
and kind of the compounding of what has came out of my career and opportunity there. And even some of the programs in middle and high school would be gone
yeah.
as far as the classes that did help me stand out because I thrived in the advanced courses.
Mm,
And that's just something to maybe as like a parting note, which is there's those trends which I think people need to be aware of, and they need to be aware of the impact of those, where in an education system with scarce resources, you
mm,
have to have some level of meritocracy, as far as some students will really want their education regardless of background, and some
yeah.
students regardless of background will reject the
Mm,
education that they face with. And with a scarce resource planet in general, whether it's the country school systems, school districts, or the entire planet,
mm.
people need to pay attention to, on a policy side, the resources and the output of these systems. And they're going in a direction that I just I don't think is sustainable.
Yeah. Yeah. And it's a weird time for I think anyone looking to get into the academic side. Going to school or college. I would tend to agree with you that I don't think college is necessarily the right option
Right.
unless it enables the things that you're good at. And
Absolutely.
and going to college, and I made this mistake. I'm still paying for it. Of going to college to learn something, you're better off learning it on your own. And
Hmm.
I'm a I'm a story for that.
Right.
So I think if there's a message we can leave people with, it's like you mentioned, like figure out the things that you're really passionate about and that you are good at, and see you're not going to find it right away,
Right.
but start looking at it and saying, okay, I do that. Taste. That's my biggest recommendation to anyone who's like an intern who comes in. I get to work with them, or a brand new employee who's coming out of college. Is just taste everything. And if at the very least you learn what you don't like,
Right.
then you don't have to waste your time on that anymore.
Right.
And best case, you find something you love, and then
Mhm.
you're in good shape.
Yeah, totally agree.
Awesome. Let's end it there. Jordan,
Perfect.
thank you so much for joining us. It's been a pleasure. I'm looking forward to see what Embed Adventures gets themselves into and all the things you're working on. Any place people can follow you online or follow the progress or get in touch?
I'd say follow Embed Adventures. That's where most of our news comes out. We have a Twitter page. We have a Twitch stream that Jenna runs actually every
Oh, great.
Thursday at 10 a.m. Pacific. She teaches students in Robeson County, North Carolina, to build an 8-bit computer
Oh,
from
sick.
scratch. That's one of our outlets we use, which is especially with Twitch because it's a hands-on platform
Yeah,
where people can watch you not as an expert, but someone learn live, and I'll be
yeah.
helping and looking up resistor codes and everything because I don't know everything. But kind of what a day in the life of an engineer actually looks like, which is a lot of Googling and a lot of Stack
Fun.
Overflow. But you can follow us there. Everything has links on our Embedded Ventures website, which is embedded.ventures for those interested. So please follow there. And you can shoot me an email if you have any questions. My email is public, but it's jordan@embedded.ventures.
Perfect. You heard it here, folks. Thank you, Jordan, again for joining us. This has been another episode of Today in Space. Another person of people science showing you all the different ways that if you want to get into science, it doesn't even necessarily need to be college. There's so many different ways you can get involved. Jordan is just another one of those people who's done it. Jenna, who eventually we'll speak with too, another person who's very deeply involved at affecting the science, technology, engineering, and math space. So, Jordan, again, thank you so much. We'll see you guys later.
Sounds good. Thank you very much.